Login accepted.
Hi, everyone. I'm super excited to be here. I'm sure you're too.
Hey, folks. Thanks for joining. We're really excited to co-present this session. Hopefully, you'll get a lot out of it. And I'll let Lize start with what we're going to talk about.
Okay. Maybe quick introduction first. I'm Lize Raes. I'm a collaborator of the LangChain4j framework. And in my day job, I work in bioinformatics as a head of AI in a company for drug discovery software.
And my name is Andrianakis. I work for Red Hat, and one of the things I do is work on Quarkus and LangChain4j.
All right. Before we start, I would be interested to know who of you uses some form of AI, like ChatGPT or something, like weekly? Okay, that's over half of the people. Has somebody already been programming with AI, using AI or LLMs inside of your program? Okay, then you will learn a lot. Not the ones that raise their hand, maybe two. Good. So let me present the LangChain4j team. This framework was started by Dimitri Liobarski over a year ago, and by now we have over 80 contributors that help us a lot, making sure we have the latest integrations with all kinds of models and model providers. So we have also people from Red Hat, from Microsoft, from Google, from AWS that are contributing all their integrations, which is super cool. So we are totally up to date. What we do with LangChain4j has nothing to do with ML ops, so the machine learning and training. That's not included at the moment. We just stay in our DevOps and developer environment, and we are using AI models via an API. We are inspired by LangChain. So the original LangChain was created for Python. I guess you've heard about it. And what LangChain does is it lets you integrate easily with different model providers and different models. So you can easily swap them and use them. And then they have a lot of functionality around these large language models, such as chaining requests. If you want to have more complex use cases, they can make agents where the LLMs is given tools to do something. And then there's a whole system also to interact with your own documents and to search in there. And we like this very much, and that's why we made this for Java. And then you liked it very much.
Yeah, and so the idea with the integration between Quarkus and LangChain4j was actually inspired by a presentation Lize did at Devoxx Belgium last October, right?
Yes.
So Lize presents, everybody was like amazed. I actually wasn't in the room, I had some work to do, but my boss comes to me, he runs out of the talk, he comes to me and he's like, you gotta see this presentation, it was amazing, and you have like half a day to make an integration with Quarkus and LangChain4j, because we need to show these people that we're very serious and we want to start collaborating. So you just get to it, start working, and that's how our collaboration started.
Yeah, that was very cool for us and for you guys, I think.
Yeah, absolutely. Turned out pretty good.
Okay, just some terminology so we're all on the same page. We will be mainly talking about large language models today. Basic language models, they do something, either completion or they will generate something very similar. It's not the ChatGPT that you know. This was the first version. We support it, but I wouldn't use it because there is a new version, chat models or instruct models. That's the ones we know from ChatGPT. They work way better in following instructions or trying to chat with you. So these chat models are the core functionality of LangChain4j. Everything's built around. And then there's also embedding models. These are special type of models that take text as input and that output a numerical vector that encodes the meaning of the phrase. Now, why would you do this? Because you can start grouping data by meaning, or you can categorize data, see which groups you have in there, and to easily find vectors or embeddings back that have a similar meaning, so close vector distance. You will usually use embedding stores that are databases that are specialized in super fast finding of similar vectors in there. We will see later why we exactly use them in LangChain4j a lot. 3 more concepts there. What we input in a model, we call it the prompt, so your query or your question. Prompt engineering is the whole art of making a language model do what you actually want. Because with like talking to a teenager, most of the time it's not going to understand you very well or behave weird. So that's why we have prompt engineers that know how to talk to these teenagers, basically. You cannot just send limitless text into a language model. You have a limited context window. And that depends a bit on the model provider. So it goes often from a couple of pages that you can input in one prompt to, for example, the Google Gemini, the latest one, you can input 1 million characters.
I think it's 2 million or something like that, but yeah,
yeah, something in that.
Increasing.
It's huge, and then you have to be very careful because you pay proportionally to how many characters you send in. If you max out on this Google Gemini's context window, it costs you about $3.50 to just make one call. So use it wisely. You also pay per output character or token. There to give you an idea, I think with OpenAI GPT 3.5, the thing that runs behind the free version of ChatGPT, I think you can output around 10 pages for 1 cent. So to give you an idea. Now there's this concept of tokens. Tokens are simply characters in the world of the models. So they will chunk up our text a bit differently than we would do. And tokens are typically around 3 characters long, and it depends a bit on the model. Okay, so these are the basic components of LangChain4j. You see here on the left the language models, of course, but we also support image models, and we hope also to support soon sound and voice models. Maybe something for the Quarkus team,
no,
or for anybody else.
Yeah, we've already been discussing this basically with the Dimitro. We definitely want this, hopefully before Devoxx Belgium in October.
By the way, it's an open source framework, so if somebody wants to use it and finds something is missing, and you can always write it and make a pull request, and we're really happy with that. Good. So language models, image models at the moment, prompt templates. We're not going to demo them in depth here, but whenever you find yourself stuck with long strings and repeating them over and over again because you want to instruct the model in the same way over and over again, prompt templates make it a bit cleaner for you. We have output parsers. That's super nice. Models are capable of outputting things in a specific format, say JSON. And LangChain4j then sometimes takes care of parsing that into real Java objects that you can continue working with. We will be demoing all of this. Memory is important because a model in itself has no state, so we have to manage this ourselves. Again, we have a lot of nice functionality to make that super easy for you. And then tools is where the model can actually call your Java code and do something with the result it gets back. Then on the right, we have RAG, Retrieval Augmented Generation, which is a hard word to say, chat with your documents. So everything in there, we will also have a look at the real example. And then we have an integration layer on top called AI services. So originally we went with the chains from LangChain4j, from LangChain, the Python version. But now we have this concept of AI services, which is more flexible and which is super nice. We will demo that too. On top you see a number of icons of different model providers. We have a huge list of integrations that come simply out of the box and that you can interchange super easily if you want to switch model, for example. If you want to know what we have currently in our integrations, let me show you. You can go to our repository. Maybe, yes. Maybe we don't want to see this.
Okay, yes.
I can type, yeah. Okay, thanks. He's now a bit handicapped with only one hand to type.
Yeah, no,
so, sorry.
Just has the challenge, no problem.
All right. Good. So here in our README, simply github.com/LangChain4j/LangChain4j. When you go to the README, here, first thing you find our LLM providers list and also our embedding stores list. And if you scroll on a bit, everything we will be demoing today can be found in these examples here. So there's plain Java examples. If you want to get started, there's a folder in there, tutorials. You can just run through it, and afterwards you're a pro. There's examples with Quarkus, and there's also an example with Spring Boot. There is even documentation. I'm very proud of that. So let's now have a look at this integration list. Okay, so here we have all the providers, and so what they all support is sync return, so you just wait until you have the full answer. But some also have streaming enabled, so then you get the output back token by token. And that's very nice for use cases where you know that your user is gonna need to read it, and instead of just waiting, like, is it working? And then they get this whole bunch of text, and then they don't even want to start reading it anymore. Streaming helps, but just it starts outputting immediately. You can start reading immediately.
And that's what ChatGPT does too.
Exactly. Right? Otherwise, it would be very annoying to use. Yeah. Good. Tools, like most of the providers have this, not all of them. Some have images, and then some compile to native, and some you can run locally on your machine, so you can use LLMs without even having an internet access. So what do we have in here in terms of providers? So Amazon Bedrock comes with AWS, Anthropic, Azure from Microsoft, the Google Gemini models, and then, for example, HuggingFace is a bit more special one. They collect all open source models that are available, so you can go download them on HuggingFace. But what they also have is whole data sets and also guidelines to train. If ever you want to train a model or fine-tune a model, they have everything you need there. And they also host if you want to run a model there. And then we have a super easy integration with LangChain4j to start using it. Two other interesting ones here are Local AI and Olama. They're both frameworks or tools to run a model locally on your computer. Depending if you have some GPU or not, that runs more or less fast. But that's very nice also for use cases where you're handling sensitive data or GDPR or whatever, and you don't want to send it to OpenAI, for example. You can just run that locally. These days, the open source models got really good. So about a month ago, there were like Llama 3 and Phi 3 that came out, one from Meta, one from Microsoft. They open sourced it, and this Phi 3 is almost as good as GPT 3.5, which is the one behind the free version of ChatGPT. It's almost as good. I think it's 100 times smaller. It's a 3.5 gigabyte download, and you have this model on your own computer. Okay. Okay.
Awesome.
Should I show it off, or
Yeah.
should you show it off?
No, go ahead, please.
Good.
Show us what we can do.
Right. Okay, so first of all, I want to show you an example that integrates a bit everything. So you know why afterwards you will be paying attention for the hello world and the stepwise build up. Okay, so we have this example using Quarkus LangChain4j. And if I run this, we have a little UI with it that will pop up on localhost. And it is customer support agent for... it will take a while. Yeah.
Go ahead and refresh it.
I will explain in the meantime. There you go. So it is customer support agent for a car rental company, Miles of Smiles. And we have the little chatbot here. This code is all open source, so you can find this in the LangChain4j Quarkus examples if you want to use it.
Yeah, we can link to everything.
We'll make it
later.
be there. Okay, so hello, I'm Miles of Smiles, customer support agent. How can I assist you today? So first thing, This is not just the model, because we've instructed it to know who it is in the first place. And if I now ask, can I cancel my booking? If I would send this to plain ChatGPT, it would probably hallucinate me that, yeah, it can need something. This is very different. What's happening behind the scene here is that this large language model knows that it has a certain role. It knows that it has tools that it could call, for example, a cancel booking tool, and it knows which input parameters it will need in that case. So what does it tell me? To assist you with canceling your booking, please provide me with your booking number and customer name and surname. So that's exactly the 3 input parameters it needs to call the cancel booking tool. So I'm going to say...
you're not typing.
I'm not typing, thank you. Good that you're here. By the way, is this breathing annoying? Okay. Good. So that's Lize Heisler, and this is my booking number. Nice thing is, this is just like free text. I don't have to abide by any web form rules. And it couldn't find a booking. That's because I made a mistake on purpose. And if we go look in the code, we should see that, yeah, there was an error thrown. And it is a... Okay, this is not my usual computer. Yeah. I have a hard time scrolling here. But it's a booking not found exception that it got. Because it called our code to try to cancel a booking. We went through our database. We see we don't have this booking here. We throw a booking not found example. And then the model interprets this and tells that it couldn't find it. So I'm going to say, oops, sorry. It's my first name, and I can make typos, that's very nice, is Klaus, of course, it's Klaus. This should find it, because this is one of the bookings we've actually saved in there. Okay, it says it found these booking details with the dates. That's good. And I'm going to say, yes, cancel the booking, because it asks if it should cancel it. So first thing, it retrieved it, and now it can cancel it. Now it says, I'm sorry, but it cannot be cancelled because the booking period is less than 3 days. And that's correct, because on top of the tools to book, so it now called the cancelling tool, it got a cannot be cancelled exception back. But on top of that, it also knows our terms of use. So there is this RAG system, chat with document system, also going on in the background. So it knows our terms of use, and if it gets this booking cannot be cancelled exception, it will have a look at the dates and at what our policy says, our cancellation policy, and come up with a really informed answer. Good.
Right. So that was a lot of stuff going on behind the scenes, right?
Yeah. Okay, so now let's build something like this, but step by step, so that when you walk out of the deep dive here, you can just at home get started and build your own chatbot or even any other type of AI-powered application.
Do we want to take questions like now or as they come in or later? What do you want to do?
Yeah. Do you want to ask questions already? I heard people in Poland are very shy to talk to women.
I've never been here, I don't know.
But he's a man, so no. Okay.
A short one.
You should wear heels.
Yeah, I know. It should come in fashion.
Right. Cool. So we will be showing how this is all built. So if you have questions now, I hope we will resolve them on the way, but then feel free to ask while we're at it. So let's say make ourselves a Hello Devoxx Poland little program. First thing, you will want to add the LangChain4j dependency. So on top, there's a core dependency. And then we also need to pick our model. So in this case, we're going to use OpenAI, the ones behind ChatGPT. But you can use all of these other integrations as well, of course. I'm going to always show the vanilla Java LangChain4j version. And then Georgios is always going to show the LangChain4j Quarkus integration, which has, of course, a bit different dependencies. Okay, let's dive into a Hello World program. Good. I'm gonna live code that here because it's bad idea, can go wrong, but I find it so easy that I still want to do it.
On not your laptop.
Oh, not my laptop. Yeah, it's gonna work. Good. So first thing we wanna have is a chat language model. I'm gonna call it model. I'm sure you're here to save me. So this is also not my usual keyboard. Good. And we want an OpenAI chat model because that's what the dependency we loaded. And the thing we will have to set in any case is a key because it doesn't come for free, this one. It's not a local one. We're going to have to set our key. We can store this in environment variables, paste it right there, but then watch out to not push it to GitHub or something. But if you don't want to create your own key on the OpenAI website, you can use the demo key and try it out a little. That only works for OpenAI, and that only works for the basic use case, just so you know. But to get started, you can use that one. Now, we're going to use this model to generate an answer. Yeah. And what are we going to ask? We're going to say, we're going to take a model, we're going to generate. And what do we send in? Say, hello, Devoxx Poland. That should do. And then we're just going to print this. Oh, we have GitHub Copilot.
Hit it.
I'm going to just hit tab.
There you go.
Good. It's something I switch off when I demo because then it just pops out your whole program right away. Okay, now when we run this, let's see what happens. So we didn't set more parameters than just...
You ran a different one, actually.
I see.
Yes.
This looks like a poem about unicorns. Okay. Why not?
So it was so smart that it went to the next step.
Okay, wait. Yes, go. Run the right one. Hello, Devoxx Poland, but with an exclamation mark that I did not ask for. So first thing to keep in mind when dealing with LLMs, it's not easy to get out of them what you exactly asked. If I would run this a couple of times, I would get everything from hello Devoxx Poland to hello Devoxx Poland, how can I help you today, to hello guys. So when you build apps, it's not deterministic what you're going to get back. And as you also saw, there's a certain latency for making these calls. Also something to keep in mind. Good. Quarkus time.
Right. So you're not going to have to suffer my live coding non-existent skills because I have one hand, so I'm just going to click on buttons here. I want to show you basically a very simple analogous example in Quarkus, right? So what we had here with plain Java is that you had to build everything on your own, right? So you have to build the OpenAI chat model. You have to pass in a key, which, like Lize said in production, this would not be here. This would be follow some kind of 12-factor thing, and you'd pass in the parameter some other way. Well, in Quarkus, all that is already handled for you, right? So in Quarkus, we basically integrate. Well, let me take it a step back. How many people have used Quarkus? How many people know what Quarkus is? Excellent. Okay, and how many people have used Spring Boot? Everybody, all the rest. Okay, cool. So basically, for those who have never used Quarkus, what Quarkus is, it's a Java framework that makes developing Java cloud-native applications very, very easy, right? So even if you don't know Quarkus, you can think of it like the programming model is very similar to Spring Boot, right? So here, what we're doing is we have the framework configure the language model. Remember, in the example that Lize showed, you had to build this on your own. But in the Quarkus example, you have the framework configure it for you, and you just inject it into your code, right? So what I'm going to do here is say, I'm adding the same thing almost. So I'm saying say hello world and nothing else. The reason I'm saying nothing else is because if I don't say nothing else, what it would do is say hello world, and then it would say like hello world has been used in the programming world for blah, blah, blah. And it would give me like 20 sentences just for a hello world thing. Now, I got the answer hello world, right? Now, the other thing is that with Quarkus, you would have to configure your OpenAI key with properties. So there are specific properties that lets you configure various aspects of the model. In this case, I have an environment variable called OpenAI key that hopefully I won't give away here. And then everything just works. So like no code almost, it just injects your model and the model works. Now,
and the model, it gets it from the POM, right? That's where
yes,
you choose.
exactly. Very good point. So in the POM, what I've configured OpenAI, right? Quarkus LangChain OpenAI. So now what the very cool advantage of this is that now if I change to Ollama, and Ollama is basically a super interesting open source project that allows you to run models locally, like on your laptop, on your desktop, whatever. You can run a lot of models, like Lize said, like Llama 3 is state of the art, local model, Phi 3 also very, very good. Now, so just by changing Quarkus LangChain4j OpenAI to Ollama, and Quarkus restarted on its own, and it printed the same thing, right? So let's see if I change this again and say, hello, Devoxx with one hand, and I make it restart. Let's see what it's going to do. Now it's going to take a while to get an answer, but it got an answer. So now what happened is that I'm running Ollama on my machine, right? So if I go to Ollama -- version, I get the latest, at least the latest from a couple days ago. And that runs the model. So this program is not sending anything over the network, right? It's running, it's actually sending this query to the local model. And that is very important, as Lize mentioned, because in your organization, you probably don't want to be sending your corporate data to OpenAI or to whoever else, both for privacy reasons and because they use your data to train their models and all that cool stuff.
I'm happy to just nuance this a little.
Absolutely.
When you use ChatGPT for free, yes, they use your data. But when you use it via API, there are some terms of use to it. They have also our enterprise terms of use, but still you have to check it off with your legal in general.
Yeah, that's always good advice, right? Talk to legal.
Yeah, it's not fun, but yeah.
Absolutely. So that just shows you like how the power of the abstractions that LangChain4j brings, that you can build this kind of stuff and not care too much about what model you're using. Now, we can take this one step further. I'm going to execute a command before I mention what it does. Now, I'm going to package the application in native mode. Who here has used or knows what GraalVM is? Wonderful, lots of folks. So for the folks who don't know, GraalVM is a wonderful project from Oracle that does a bunch of things. The one thing we care about in this talk is that it allows us to take a Java application and convert it to a native binary, right? In this case, because I'm using Linux, this will convert to a ELF binary. And among the very cool, let's say, advantages that this has is that the application is very, very small when it runs. Like it'll take like 10, 20, 30 megabyte of RAM to run this application, and it will start instantly. So we're talking about like 10, 20, 30 milliseconds. What we're seeing here is the compilation process that GraalVM takes the jar that Quarkus creates and passes it through an extra compilation step in order to create the native binary. Now, this process of creating native binary is relatively heavy. That's why I ran the command before babbling along about what GraalVM is. It should take, on this laptop, it should take, I don't know, about a minute and a half. But when we're done, we will get a native executable that does not need Java at all to run. It's a standalone native executable like you would get with Go or Rust or any of that cool hipster stuff. So now let's try and run this. And I think this is it, the runner, right? So this is the binary. It started instantly in 16 milliseconds, and it responded, right? So here we have a native application that runs against a local model, right? And with no code changes at all. So we took the same application and just a change to a llama, passed one flag to build it in native, and everything just works, right?
Awesome Quarkus stuff. that's
So
why
that was the
super
hello
happy.
world, right? So
was
now
hello
we have
world.
a whole lot of other stuff.
Extended hello world. Okay.
Sorry, we have a question.
Yeah.
The question was, is the application we're running on a different port? Okay, very, very good point. Right. So the model is being served by the Ollama server. Okay. The Ollama server by default runs at a port like 37 something. I don't remember exactly, but Quarkus automatically configures that for you, right? When you're running locally, like it has all the defaults. Now, if you had like a corporate Ollama server that was running somewhere in your corporation on your network, then you would just pass one flag to Quarkus, which would be like the Quarkus.langchain4j.ollama.url, which would be like some server, some port, and everything would just continue to work, right? Now, I just want one point. At some point, I'm hoping in Java we will be able to do this, but what you're asking, basically running inference in the same Java process. Hopefully in a couple years, the ecosystem will be there, but it's not really there today.
But they're definitely on it.
Yeah.
Direct GPU access from Java.
Exactly.
Yeah.
That's very exciting stuff.
Okay. This one is still running. Oh, well, we'll switch it off afterwards. Good. Next thing. These AI services. LLMs returning plain old Java objects. So let me show you how that works. Yes. Good. So I will first show you a really, really basic AI service. By the way, can you all read the screen, or should we put it bigger? Can you read it? Good. Good. Yeah, sorry, this computer scrolls up and down inverse from mine, so I'm always a bit confused. Good. So we have again a chat language model, again OpenAI chat model, and this is here you see that we set some parameters on top of it. So then we're going to use a builder this time, and then so the key gets set, but also a timeout. And just to show you how nice this is in LangChain4j, you do dot and you see all other parameters you could set. Like you can choose your model name there, whether to log requests and responses, set temperature, all that kind of interesting stuff. If you don't set anything, we choose the same defaults for you. Good. Now, AI services, it's a bit of a weird concept to wrap your head around, so I give this very basic example that's not very useful to then show you afterwards how you can make it really cool. An AI service, you will always declare as an interface, and you just declare what you want it to do. So this time we call it assistant, and this one has one method, chat, that takes in a string as input, and that outputs another string. What LangChain4j will do in the background is say, oh, string in, string out, it's just a simple call to the model. So this is the most basic AI services you can have with a chat method in. Then LangChain4j allows you to create an instance of that object. So you do AI services.create from this assistant class that we just defined here. And we specify which model it should use. And now we actually have an assistant, and we can use this chat method. So I will run it here to say assistant.chat from translate plus-value des sessions de valeur, something of my French text form that I don't understand, so I want it translated. So now when I run this should work. So I didn't really code what it has to do, I just declared this interface. And what I get back is capital gains from the sale of securities, and something I still don't understand, but yeah, I can then ask extra information. Now, anyway, this was just to show you what is a basic AI interface. Now, why would we want to do this? Because you can do a lot of extensions to it. So here is an AI service with 3 methods in it. So we call it text utils, and it has a translator method, summarize, and extract date time from. So let's take them one by one. Translate has a system message annotation on top of it. System message, it's a general instruction for your model that applies all the time. So it says you are a professional translator into, and then into this language, which we take from the first input variable string, second one, the string language here. Then we also make a user message annotation. That's what we really ask, that's our prompt. Translate the following text, and then we insert this text here that's also annotated as a variable. So 2 input variables, string text, string language, and we get back a string. So LangChain4j then takes care of wrapping this correctly for the model, so this should work. Our summarize method also has 2 input arguments, a string text, and an integer n. And it has a system message saying summarize every message from the user into n bullet points. Provide only bullet points. Again, we have to be a bit clear here, or it's going to give us a whole explanation around, and we don't want that. Why we don't want that is because we ask a list of strings back here. So when we are going to call summarize, we get the real Java object list of strings back, and we can continue from there. The text has been annotated as the user message because that's what we actually ask to the model. And then the last one, who of you likes to juggle around with all kind of date time objects and date time parsing? Yes, we have 1 person. Neurodivergent.
We'll talk to you later.
Good. For all the rest, I think you must hate it as much as me. So this is where LLMs can also help you. We have extract date time from a text. And what we're going to send in as prompt is extract date and time from it, being this text. And what we're going to get back is a local date time object, right away parsed for you. And then we don't have to care anymore. Good. Now we're going to use these methods. So first thing is to, again, call AI services.create from these text utils, and we give a model. And then we're going to use them. So we're going to do utils.translate hello, how are you to Italian, and print the translation. Then, sorry for then we're going to use utils.summarize. We're going to summarize this text about artificial intelligence into 3 bullet points. And then we're going to print them because it's going to return a real list, and then we're going to print each line in there. And then the last one is here. We're going to extract date time from this text here. And this text is a bit bonkers. The tranquility pervaded the evening of 1968, just 15 minutes shy of midnight, following the celebrations of Independence Day. And we want the local date time object back from that. So let's run it and see what our, in this case, GPT 3.5 will make out of this. So we have ciao come stai, which is indeed Italian for hello, how are you? And then we have this 3-point summary list. And then here we have our local datetime object that we printed. So the year is correct. That is 1986, just 15 minutes shy of midnight, which is also correct. And then I'm sure if the date you go look it up, it's also correct. So this is a whole different way of programming. And it's also a use case that we could not even solve before, like deal with these records describing dates and people, and you can extract all these objects now from your text, thanks to these large language models. Okay, let's take it 1 step further. We can also declare our own POJO and have it return our POJO. So in this example, I have a recipe object that I made, and I say it has 4 fields, a string title, string description, a list of string with steps, and an int preparation time in minutes. And if you want, if the name of the variable isn't clear enough by itself, you can optionally add a description annotation, in this case a short title, 3 words maximum, or each step should be described in 6 to 8 words. Steps should rhyme with each other. Why not? Good. So this is our recipe object. It has a print method, so we can then have a look afterwards. Good. And then we're going to create an AI service, a chef. It's again, this is just an interface declaration, create recipe from a variable number of strings, and it returns our recipe POJO. And then we're going to create it again. So we have our chef, and we say create a recipe from cucumber, tomato, feta, onion, olives, and lemon. Does somebody want to add something disgusting to this list, just to see? That's good. That's good. No, I don't think that's disgusting. I also have no clue how you write that in English. Like,
It'll figure it out, right? It's smart enough.
definitely not like this. Okay, but it's smarter than me, so it will figure out. Okay, let's see if it can make us a recipe object with these ingredients, and hopefully rhyming steps. Good. So Greek salad delight. And the steps are chop, mix, and toss ingredients together. Drizzle with lemon and olive oil. Serve, and it's not rhyming. Sometimes it doesn't matter. It's not even saying which the ingredients are.
Well, we can run it again, right? See what
Let's run it again.
See what happens. And that Lize said this in the beginning, right? The one thing to absolutely understand is that these are not deterministic. Nice.
I think it's the anchovy.
The anchovies.
It's probably telling me
take out those anchovies and see what happens.
So what LangChain4j does in the background is say you have to strictly answer in the following JSON format, and then it parses whatever POJO I defined there in JSON. And it may be like when you get these null issues, it's probably because the model answered something completely different, like you shouldn't be putting anchovies in your Greek salad, or this is not how you write anchovies. Okay, let's be kinder and have a proper Greek salad. God, it's not a good day today.
Yeah, we really messed with it.
Oh, so that's a pity.
Again, this just shows you that you need to be very careful, like when using these. There you go. I mean, it works well, because the answer is potentially different every time, right?
Okay.
This is a neural network. It gives you different answers. There's a bunch of parameters to tune, but still, you can like never get a same answer for sure, right?
Yeah. Interestingly, though, this parsing of whatever JSON we got back from the model clearly failed in these other couple of cases. I must say 9 out of 10, this one does work. So we have a retry option, and you can also define some fail criterion. So you say, oh, if my answer doesn't whatever follow the structure I want or contain what I want or is null, just run it again. And then you up your chances of having a proper answer by a lot, because 9 out of 10, it actually does its job well. Okay, you want to show the Quarkus version?
So yeah, the Quarkus version. The essence of the Quarkus version is basically that we allow you to just get the interface without having to actually build it, right? Now we should also mention that I got it.
I can hold it for you.
I got things. Yeah, sure. No, thanks. This AI service has a bunch of options, right? This is like the simplest possible one. Here you can pass in memory, tools, RAG stuff. Like when you create one, a real world one, this will be a lot more advanced. But with Quarkus, all those advanced options are pre-populated automatically based on like defaults and the programming model that the CDI programming model, right? So here, let's take the first one, right? Actually, no, let's take the same one, Chef. We have the Chef AI service. So again, it should be the interface we had here. Recipe from ingredients. Okay, AI service declaration. It has all this. This should just work. And now, what Quarkus does basically, well, if I can find it here, is that by using this annotation, this register AI service, it will create a bean for you that you can then just inject into the application versus having to actually build AI, do the AI service.create that we had earlier. And it applies a whole bunch of defaults that we'll see later on as well. But let's go ahead and run that now and see what happens. AI service. This one. Let's see if we're going to have any luck this time.
If you didn't put anchovies in it, there's a chance.
Yeah, I didn't. So let's hope it's smart enough this time. There you go.
Yeah, looked.
There it is. Mediterranean salad. So it doesn't call it a Greek salad this time. It calls it a Mediterranean salad. Fresh and zesty salad with a twist, chopped cucumber, blah, 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 blah. Yeah. So same result in this case. It's just that in the Quarkus case, you basically only had to inject the assistant, the chef. We were talking about the chef. You just have to inject it into your code, and annotate the chef with register AI service, and everything else just works.
I know why they didn't call it Greek salad, because we've accidentally pushed some little thing that I wanted to demonstrate in the Netherlands recently, and we asked it, where is it that it's called with the ingredient lists?
Yeah.
Or is maybe in another...
Here we are.
No.
Here
Yes, there.
yes.
Yeah, exactly. Yeah, there's instead of feta, we have a frietsaus in there, which is I'm Belgian, which is the disgusting Dutch version of mayonnaise.
Yeah.
And that's why I didn't call it Greek salad in the end.
Okay.
But apparently that works.
Yeah, I got close enough. Mediterranean, close enough. Yeah, so you just
Good.
go ahead and close that one so we don't have a problem later.
All right.
Excellent.
Good. Next up is this memory. So models in say are stateless. You can send in I'm Lize, and then you ask next time when you call it, who am I? It will not know it. It's basically, this model is a huge calculation scheme. That's it. So if we want to have a memory, we have to manage this. Now, LangChain4j makes it super easy for you to manage this, but I still want to explain you what's actually going on. So you pass, every time you want the model to remember what has been said before, you have to pass it to the model. And most models provide an interface where you can actually do this. So what you pass is this system message. Again, it's a general instruction that applies for your entire conversation, such as you're talking to a 3-year-old. And then you pass the messages that has been sent. So in this case of this example, up to here, we have already asked a first question, got a first answer, asked a follow-up question, got a follow-up answer. And then at this moment in time, when we want to ask our third question, we're not just going to send this, we're going to send everything that's been said before. And this will allow us to get an informed answer. So you see the LangChain4j objects, their user message, our prompt, our question, and AI message, whatever we got back from the model. Now, when you would look into the real call that's happened, the API call that happens, it will be called, I think for OpenAI, AI message it's called assistant, and user message is called user, I think, and it differs from model to model. And that's the nice thing about LangChain4j, like you can just swap model. These concept tools, they keep existing. You don't have to change anything. And LangChain4j does then make sure to map it to the right settings for that model.
Yeah, so like we did with Ollama, right? With Ollama and OpenAI, the REST APIs are totally different.
Yeah.
But with LangChain4j, it doesn't matter. We just changed it and it worked.
Yeah, exactly. Okay, I want to quickly demo how you add memory to an AI service. And this is another place why you want to be using AI services. Because it makes it super easy to add the memory. So again, we have here this super basic AI services that has just a chat, string in, string out. And then we make a chat memory. And we have a couple of default implementations. So LangChain4j is all interfaces with default implementations. If you want to add your own model, your own type of memory, or whatever, you can make your own implementation. And if you think it's of general use, feel free to make a pull request and everybody else can use it too. So the type of memory we use here is a message window chat memory with max messages 10. So it means after 10 of those blocks that I showed before, it just gets cut off and discarded. So why do we want to limit the memory? Because remember this context window, it's not limitless, and also it costs us per token, basically. So it's another reason to chunk the memory. But you could think of smarter ways, like you could summarize everything that has been said before with each question you ask. Then you're sure it stays short and you're sure most of the information is still there. Just for example. So we cut off after 10 messages in this case, and then we have this chat memory. We build a model again. With the Quarkus integration, this is just an application property. No, not even. It's just in the POM. Yeah. You don't have to care at all. But this vanilla version. And then when we're going to make our AI service from this basic assistant, this time instead of create, we're going to use the builder because we want to set not only the model, but also the chat memory. And that's how easy it is. Now I can use this assistant and it will have a memory that's taken care of. So just for the demo here, first time we say assistant.chat, we say, hello, my name is Gandalf. And then we call it another time, it's chat method, and we ask what's my name. And we're just gonna print the 2 responses. And it should remember because we added this chat memory. Good. So first, hello Gandalf. How can I assist you today? Surprise, surprise. And then your name is Gandalf as an answer on our second question. So that's how easy it is to start using memory with LangChain4j. But there's also some nice trick I want to show you. That's a kind of abuse of the memory. There is a technique called few shot, where you can fake a memory to make the model behave like you want it. You're going to pretend it has already behaved and answered like this a couple of times. You pretend that was in the memory, and it's going to very, very well follow whatever you gave it as an example. And sometimes way easier to give it some examples than to say, you should answer in this and this and this format. So the example I have here, again, I make a chat memory. This time, just to show you, there's token window chat memory. So then you chunk off after tokens with maximum 1,000 tokenizers. And then we have to pass the tokenizer along because the tokens depend on the model. And we are using GPT 3.5 Turbo, so then it knows. Good, we have this memory that chunks off after 1,000 tokens. And then I'm going to populate it with examples. I don't know your shortcut to jump there. Wait, maybe.
Control B.
Control B, okay.
Yeah.
I'll try to remember that. Okay, so in populate with examples, I gave 4 examples. A positive, a negative, one more positive, one more negative. And what I want to get out of there is this. I say things like, so the user message I put in this memory is, I love the new update, the interface is very user-friendly, and da-da-da-da. And what I then put afterwards is an AI message, so the so-called reply of the model. And reply is this action, forward input to positive feedback storage, new line, reply, thank you very much, and then some very kind reply. Imagine I want it like this, because then afterwards I want to handle it a certain way, and I want to cut on that new line. Now, I put also a negative feedback example. I am facing frequent crashes after the new update, and then the answer I'm going to add to the memory, all as if it has been said, is action, open a new ticket with a subject for it, new line and a reply, we're so sorry, da 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 da. Then one more positive, one more negative, just the same way, and that's it. So I've put this in my memory, and when this time I will build my AI service here, I'm gonna add just that memory, but it has already some stuff in there. Next thing is that I'm gonna use my chat method, and I'm gonna say, how can your app be so slow? Please do something about it. And yeah, that's what I always, when I get to put reviews, it's that. Good. So when I run this, it says, action, open a new ticket, app performance slow, new line, reply, and then a big kind reply. And I didn't tell it like how to behave. I just pretended it had behaved like that beforehand. So that's really powerful.
Question.
Yeah. Yeah, I do not think I've been seeing discussions going on. Yeah, it would make sense to keep them on top, right? And maybe throw away all the rest. I don't think we have an implementation yet, but I also think it's coming soon. Yeah, so we're discussing. Yeah, that's or right. You can make one. This is really not hard to actually make, and then pull request. Few shot memory. Mm-hmm. We have a name for it. Yeah. Quarkus version of memory. So
Quarkus version, we're not going to go through the whole thing again because we get the gist. What I just want to show you really quickly is that in memory. So let me make this a little smaller so we can get more real estate here. So again, we have the assistant, right? And we have, I've commented out the second thing, so we're only going to show the Gandalf one. But what we have here is that we have done nothing to configure memory in this case. That's because in the Quarkus version, there is an in-process memory configured with each AI service automatically. That's what we assume the basic default should be. So we automatically configure it. You can turn that off if you don't want to. So if you want it to be completely stateless, which there are use cases, you can absolutely do that. But here we just, like zero configuration, you have memory. Let's run it and see what happens. Let's see. So it starts.
So as you can see, to get these Quarkus programs running, it's a bit longer than your vanilla Java, but when you use it as a program...
Yeah, in this case, because it's running the dev mode, which will show exactly what it is in a second. It's compiling everything, and it's starting up like a version that detects changes automatically and things like that.
But the strength of Quarkus is exactly that when you actually compile it, it's super fast.
Yeah. So the production version of the application like is faster than anything that you will find in this class, right? So in like an enterprise grade framework, it's the we have found at least it's to be the fastest. Now, obviously, there's nothing as fast as like just writing plain Java because that doesn't have any abstractions. But when you actually like want to go to production and solve enterprise use cases, it's very hard to come up with all these abstractions on your own, right? So here, what we had is we were just telling it you're Gandalf, so it says hello Gandalf, and then the proof that the memory works is that it comes back and says your name is Gandalf. Although we didn't configure anything, like I said, it's a default. So very similar to like what Spring Boot does with it adds a lot of beans by default. Same idea in Quarkus, and in the case of LangChain4j, we've taken it to another step, right?
Okay, we'll give you
turn that off. Yeah.
10 minutes pause afterwards, but I want to show you one last thing before the pause to get your mind running. I want to show you. We'll show that after, baby.
Yeah, for sure.
Let's get the tools first.
Yeah.
Good. Tools. So tools are a way of letting the model know it can call our Java code, and from our Java code, it can of course call anything else like database. Scrolling the internet, whatever tool you give it, what you think makes sense for your application, you can give that to the LLM. Do that with care, right? All the normal security rules keep applying, and you have to think even much more because it's not non-deterministic what the model can do, and people can like do prompt injection and make it do things you never intended it to do. Now, I have a bit of a dummy example for tools. And I'm going to show you before the pause, and then you can think what all cool things you can build when you have these tools, and then you can show the real cool example afterwards. Good. So tools, that's here we have a class calculator, and we have a couple of methods in that which we annotate as tool with optionally a description. If it's not clear from the name of the method, then you can give a description. Now, I said it's not very smart, this one. We have a tool string length, a tool add for 2 integers, and a square root for an integer that returns a double. And as you see, we're also always printing this now to console. That's just for this demo, so you see that this code is actually being called. Okay, so we have this class with these tool annotated methods in there. We again make our simple AI assistant. We pick a model. Let me put these logs and files because otherwise it becomes a huge mess. But it's interesting. I mean, if you want to observe what's really sent to OpenAI and what OpenAI really sends back, how it actually calls our methods, how we send the answers, you can log requests and responses and have a look. Good, and then we build our AI service again, our assistants. We give it a memory, we give it our tools. That's new with this step, and then it needs a model. And we're gonna ask it this question. What is the square root of the sum of the numbers of the letters in the words hello and world? Again, it's a bit not so real world use case, but then you can see how the model calls these tools because it's informed that it has them available. So you see it called string length twice, with hello and with world. Then it called our add method with 5 and 5. And then it called the square root method with 10. And so that's all this was printed through console from our methods. What the model in the end really answers is this. The square root of the sum of the numbers of the letters in the words hello and world is approximately, and then it gives us the correct answer, but very wrapped in a very nice way. Good. With that, I would say 10 minutes pause. And yeah, I invite you to think a bit about once you have tools, once you can let models actually perform things or calculate things or retrieve things, what cool applications you can build. Good. Enjoy.
Okay, yeah, so 10-minute break, and then we'll come back with a bunch more demos for you.